Hello and welcome everyone to this video tutorial where we'll design a 6-story building, and you can see the plan of this building, the manual document, and all the other study materials. I've also attached an Excel sheet in which I've given all the details. So all of these you can download from the link in the description so that you can practice along with me. So what we are going to be doing is we are going to be making this building, and we are going to compare some of the results of shear force, bending moment, and also essentially the base shear, so that we can know whether our STAAD modeling process is correct or not. And you can see this study this document which you will download as well. Okay, so let's get started here. First of all, you can see this is the plan of this particular building here, and this is actually art gallery. So in the middle there will be only beams, but there will be no walls, and you can have this secondary walls as well, secondary beams as well, sorry. And you can have this coordinates, so you can know that instead the default coordinate system is like this: x is like in this direction, z is in this direction, if you see from the top view. Okay, so in this way you can just mark the coordinates. As you can see, this coordinate is marked, but this is according to other coordinate system. So I've just marked the coordinates here according to this. I'm just given this in the Excel sheet. You can see I've marked the coordinates here like this, so that in the top view it appears, the building appears like this as drawn in the plan. Okay, so so that we can easily do it in STAAD. So in STAAD.Pro, so we will begin this software here, and you can just name this structure 2. Okay, make sure you have metric on, and then select your folder and then click on create. Okay, so now we are going to insert the nodes, and you can see in the Excel file, you can, if you want, you can just practice and match your all your coordinates and then paste. It will be better. Otherwise, if you know already how to do the coordinate system, just paste it from the Excel sheet. No worries in that regard. So you can see this is the coordinates which have been pasted. So you can go to the top view here, and you can then select, go to geometry, and then you can click on add beam, and then we can add the beams here. Okay, so while adding beams, now there will won't be any problem, but later when an option comes, like if you misclick somewhere, an option comes, do you want to add a node here? So just click on no. This means you have misclicked. Okay, suppose I click here, so this saying, do you want to add a node here? No, because sometimes you can misclick. Okay, I'm not zooming too much so that I can easily do this. So if that option comes, just click on no, because we don't want to add node, means we have misclicked. Just click on escape command, click on escape to go back to the beam cursor. So this is the beam cursor, as you know. So now this particular building, if you just study the document, this is the G+6 building, and the ground floor height, if you see, ground floor height is actually 4.1 meter, and the remaining height, you can see, this is 5 meter. Okay, so ground floor height is 4 meter, and that below the ground floor, we have the 1.1 meter is the GL, and one below, and the 1.1 meter, 2.5 meter. After that, this is the foundation level. So foundation level will give in the when you do the seismic analysis, but let's see. Okay, so let's draw the GL here. Okay, for drawing the GL, we'll go to select and go to the node cursor here, select this easily, and then we'll go to geometry, and we'll use the option of translation repeat, and this is obviously in the y direction here, and there will be link steps on, and this will be minus 1.1, so in the bottom direction. Okay, minus 1.1, link steps on, and click on OK, and you can see the effect here. View and display whole structure, you can see the effect here. So this is 1.1 meter selected. So I want to quickly just draw the supports here. You can go one by one, but I'm just to draw the supports here and get rid of this step. Click on add fixed support. This denotes the connection between the column and the footing, and assign, and yes, and we'll check here in the display whole structure that all of them are attached to mark. Okay, so go back to geometry here, because geometry steps are not completed, but just completed this particular step of fixed connection here. So the next step is we can do link steps, and in the ground floor there are no secondary beams. Okay, in the ground floor there are no secondary beams. In the next floor there are secondary beams. Okay, so let's go to the next floor here. While you go to view, by the way, you can study the document properly so that I can just know this. So you can just select this. Okay, you can see this is selected like this. We can do link steps because all of these there are no secondary beams here, so we can do link steps. So you go to geometry, translation, repeat, and y direction, and number of steps will only be 1 because then the next step will do secondary beams and then we'll proceed. Okay, so default step spacing is 4.1 here for the first step. Okay, spacing is different, and then we'll do link steps and then click on OK. So you can see this is done here. Now for this step we need to do some extra things. So we'll go to view and go to front view and select this one and right click and click on new view. Click on OK, and then from the top view you'll see here we are seeing this as a top view. So now we need to add some secondary beams here. So you can select all the areas where you have the secondary beams here from the PDF. So you can see here left, the orientation is simple here, left right then top bottom, then left right and left right and then top bottom and left right, like this it is there. So like this we have to do this. So starting is left and right. Okay, so you select this, control and select this, and then the top. Okay, top and bottom and then left and then right, and then obviously the top, bottom, left, right. Okay, top, bottom, so and then left and then right, top, bottom, left, right. Hope we've done this. Right click and then you have insert node option, add n number of points, then equal to 2, click on OK. So now go to geometry, add beam and add the beams here. So we're adding the secondary beams here. Be careful while assigning the beam so that you don't overlap on any other point. And also there has to be order in which you draw. That is very important, because if you have proper order, like for this I'm doing the left one first and then the right one, and then now for this I'm doing the bottom one first and then the top one. So always have an order. So when you have this particular habit of this proper order, then in complicated structures also practically you will not face any problems. Otherwise you can forget easily. Okay, so you can see this is done, and but now there is one thing. So all these things are secondary beams and these are pinned at both ends. Okay, so there is no column here, so these are pinned at both ends. So here I want to just complete these steps here. You go to specification and go to beam here, and here we'll go to release and we'll go to release the start here first, and start and end both are released here. By the way, if you want to see start and end, you can just right click and click on labels, and you can just turn this on and you can apply here. The green is the start for each beam and the right is the end for each beam. You can see bottom, the left, right. The bottom is green and this is top, blue. So like this it is there. So I'm just turning off this, not required, because actually all the secondary beams in both ends they are pinned. So here we'll go to beam again, and in this I'll just release the moment mx, my, mz in the start, and similarly go to beam again, and at the end also we'll release mx, my, mz and click on add. So this one we'll just select and select this, control and select this, select, control and select this. You can right click, if you go from right to left, then everything it touches, it will be selected, right? It is like AutoCAD. So do this selection. So suppose I am going from left to right, so it's not selected, right? It is also selected. Okay, so like this it is selected, and click on assign and yes, and this also assign and yes. So this one, this particular step of making this pinned, or in this case you can also assume this is simply supported because both ends are pinned. So this step is done. So Once this step is done, you can go to view, and you can go to maybe isometric view. Okay, and in the isometric view we can do translation repeat. Okay, so for doing the translation repeat, select this. Okay, select this, and we cannot do link steps here because you can see these connections, you can see these secondary connections will also have, you know, columns here, but we don't have any columns here. So when you have secondary, that's why you cannot do link steps. I see many of these comments in the in my comments on all the videos, why you're not using link steps. We cannot use link steps in all the structures because of this. In the secondary also there some column will appear. Okay, so that's why. So you see the video first, and then I hope this many of you comment this, then this answer is there. Okay, so now, okay, this is done. We cannot do link steps, but we can do translation repeat. So just do translation repeat here in the y direction, obviously, and we'll do one step. Why we'll do one step, I'll just tell you after this. Okay, so just do one step here, and 5 meter is the distance here, obviously, and we'll not do link steps here, and then click on OK. Okay, so click on OK here, and I'll go forward to this particular view, and now only bottom one I'll select and right click and click on new view and click on OK, and then I'll just select the top view, obviously. Now I'll go to select and select the node cursor, and now I can select the nodes which has the main beams. Okay, which has the column, sorry, and not the secondary beams. So once these are selected like this, now I can do translation repeat. Okay, so geometry translation repeat for this particular node, y direction, and 5 meter link steps, and click on OK. And now I can go view and display the whole structure. Okay, so you can see, just click on escape to go back to the beam cursor. You can see this. So now there is 2 floors already done, 4 more floors are remaining. So we'll go to the front view and simply we'll select this particular floor like this, as you can see here, and we'll use option translation repeat here to create 4 more steps. Y direction 5 meter, number of steps is 4. Okay, so 4 more steps will be created, 2 are already there, so total there will be 6. Okay, link step is not required because we selected the columns here. Click on OK here, and you can see this building has been done. Okay, so this has been done. You can see it is blue because this is when you select this comes blue. When you select this, the end start comes blue. So like this blue selection is there. So we are pretty much done with the geometries part. So let's go to the properties. So the first properties which we will define is as per the document here. I can see the beam sizes and all there they've given here. So they've given column below plinth level as 600 600. So let's define that first, and define rectangle, and here 0.6 and 0.6. Click on add, and the columns above plinth level is 500 500. So let's define that also, 0.5 and 5. On add, and then they have our main beams are 300 into 600. So let's define that also. So 300 into 600 is the depth. Click on add, and then the secondary beams are 200 into 500. Let's define that also. Secondary beams 200 into 500 defined, and then we have the ground beams, which is the beams of the plinth level. Basically, we can call this as plinth beams also. So these are 300 to 600, 300 600 already defined, so no, not required. LBC will not require here. Okay, then simply close this. So first of all, we'll select this 600 to 600. We'll go to front view, and we'll just try to select this. Okay, select this, and select this, select this, and select this. Let's see if everything has been selected here like this. You can see bottom part has been selected. Click on assign to select beams, assign, and yes, very good. And now we can easily, what we can do, I think we can select like this, except the bottom part. Select like this and right click and click on new view. Click on OK here, and see the structure from here. Now next part, we'll just select this, select parallel to Y, and then assign to selected beams, assign, and yes. So now this particular 300 into 600, as you can see, this is for the ground beams as well as for the main beam. So all the main beams have 300 to 600 basically, which are saying this. So what we are going to do, we are going to go and select this parallel to X and parallel to Z, and then we are going to go in the top view, and go to top view, and we're going to deselect this using control and deselect this. Okay, so just to see in the 3D view, you can see all the beams are connected, periphery beams and all the main beams actually are connected, and click on assign and click on yes. So this is done, and now we have to select the secondary beams. So the secondary beams selected this like this here, and here we can do the same step. Okay, or let's try selecting from the top here. Go to top view and selecting from the top view like this. Use control to select this, and we'll see. Oh, this I've missed. Okay, like this they have selected, and then click on assign and click on yes. Okay, let's see here. You can see all the secondary beams are selected here. Okay, so we are not providing any slab since they have included the dead weight of the slab in this particular connection in calculation. So we are not considering any slab here. Okay, so slabs are not considered. So we go to materials. Materials is concrete. This is already defined. Specifications, we have already done the specification for the start and end. We are not considering text section here because they have not mentioned in the document, and supports we have done, and we will go to loading. Okay, so before going to loading, I'm just going to select this display whole structure, and I'm going to create two number of groups here. Because why two number of groups? You can see they have provided in the dead load here. We will just go in the dead load part. So dead load on terrace and dead load on other floors, they have done like this. Okay, so like this they have done. So that's why dead load, that is when you will apply the floor load. For this we will just create groups. So in the floor load, there is no floor load in the bottom part because there is no slab here. It rests directly on the compacted earth, so there is no this thing here. So we'll just select this 2, 3, 4 and 5. This is a typical floors, other floors, Alt plus G. So this group name will be let's do this TYP, or other floors you can do other floors. Okay, other floors, and this name will be floor, type will be floor, and click on OK. This you can associate. Okay, and just outside, click outside and click on highlight. Select this and click on highlight, and you can see this is associated. Okay, so similarly create, select this and then create, and then this will be terrace floor. Terrace floor type is obviously floor. Okay, I've just it's given gap. You cannot give any gap here. Sorry, forgot that. Just write it again. Terrace floor. Click on OK and click on associate. So just outside click and then select, click on highlight. Highlight this outside click and click on highlight. So you can see this is properly done. So we can just do a step before we do anything here. Go to definitions here, go to seismic definition, click on add. So seismic definition has been given here, we'll do as per that. So just select the code. They have gone with the old code. This is a old document, so they're gone by IS 2002, 1893 2002. So select this 2002 and click on generate here, and this is the connect edition, by the way. Okay, so zone, they have defined zone as 3. Okay, you can see this parameters here. These parameters are given page number 13 in the document. 13 means in the PDF. Like if you just go in the PDF and type this 13 here, you get these parameters here. You can see. seismic weight parameters. So you'll get this here, T, time period, Z, everything I've taken and just written it here just to for the comfort of you guys. Okay, so zone 3 and special moment existing frame obviously, and it is importance factor 1.5 they've given, medium soil they have given, and damping ratio 5%, foundation depth is 2.5 meter, and time period they have calculated as 0.97. okay, 0.97 seconds. You can see this the calculation here, 0.97. SFG is not required now, and importance factor 1.5 they have taken. Okay, so like this they have done, and click on generate. Okay, click on add. So here you can just check this and sometimes it has some errors, so that's why I'm going to go to command file and just check this one. By the way, call the command file in the latest version. Earlier we used to call the STAAD editor. Okay, so I also sometimes call this STAAD editor by mistake. So C define 190 load, reference factor 1.5, impedance 5 and impedance factor 1.5, SS2 it's okay, ST1 okay, DM is the damping ratio, and now okay, see PX and PZ. So you can see this error sometimes happens here if you are using some version. So you can see DT PX 2.5 and PZ it is 0.97 and DT is also 0.97. Actually DT is the depth of the foundation, so this will be 2.5. Sometimes this error comes. Okay, that's why I'm showing you this. If you are using this connect series 0.97. okay, so 0.97 is the time period in X direction, 0.97 is Z direction, and depth of foundation is 2.5, and important factor is 1.5. It is, this one is for special moment resisting frame. This is the zone factor for zone 3. So this is and type 2 soil. So this is okay here. Okay, now it is okay. Just save this and close this. So this error occurs sometimes, that's why I'm just showing you. Actually another thing you can change, but we'll change it later. Okay, so this thing you have to just to make sure you do this. Now you can see also, you can see this is okay here, driver structure 1. Now this is okay. This thing you can check. Now go to load case detail and add the loads here, and the remaining seismic weight here we'll do afterwards, just to do in the STAAD editor itself, so that we don't have to do much work. So here we have this seismic here I will add, and this will be SLX, because they have told to add SLX and SLZ. They have not asked to add SLY, that is the vertical direction. They have not asked because obviously this is a zone 3, so not required anyway. So SLX, and then click on add, and then this will be SLY, and then click on add, and then we have the dead load, that will be TL. Click on add, and then we have the live load, and we click on LL, click on add. Okay, so once these are added, so we go to SLX here and click on add, and then just go to here seismic loads. In the X direction add 1 and close this. Why? So okay, this is not SLY, it will be SLZ. Okay, this name SLZ. Okay, change it, close SLZ. Click on add here, and seismic loads in the Z direction, click on 1. So these are added here, and now we'll go to dead load. Okay, dead load. Now first of all let us add the dead loads here. Self weight, okay, self weight -1, Y, add, close. Self weight assigned to Q, assign, and yes, self weight has been assigned. Now second dead load is the wall loads. Let's add the wall loads plus first floor loads. Okay, not the floor load, sorry, member load. Wall load will be member load. Okay, member loads here. Let's see what are the wall loads are generally given. This wall loads are given actually. So for the parapet it is 4.9. You can see the calculation here. Parapet is 4.9, and for the other floors, only outer walls are there, because inner wall there are no walls, because this is an art gallery. And for the ground floor, since the height is less, this is the calculation. So 4.9, 21.6, so 21.6, 17.2 and 4.9. okay, so first I'll add 21.6, click on add, close, and next we'll add 17.2, add, and then next we'll add here 4.9. okay, that's 4.9. click on add. These are added here. We can just do that, but member load also, flow load also, let's assign here itself. okay, flow load. Now flow load, here we have on terrace there is 5.5 dead load on terrace. So here by the way, you can see this in page number 7 here. I'm just showing you page, just type 7, enter, and then you can see this is the dead load, and this is the first one dead load and live load for terrace and typical. So here I took this just for preference here. Okay, so for terrace it is 5.5, and flow load, just we'll add group here, one-way distribution since all are one-way slab, and minus 5.5. this one is for the terrace floor, right? And click on add. And then for the other floors it is 3.5. why terrace is more? Because the waterproofing they were added, and then the coating they have added, so that's why. The other floors is 3.5, so minus 3.5, right? Minus 3.5, all other floors one-way distribution. okay, and click on add. So this has been added, other floors have been added, and also the terrace floor has been added in the dead load part. Okay, now we can close this. So this has already been defined. You can see red, blue one is the selected one, already been defined. So now we not only define this. So first of all, let's go start with 17, because this is the bottom floor. Okay, go to view, go to front view, and select this, and right click, sorry, this one only, and right click and click on new view, click on OK, and then we put the top view here, and then we select, make sure you select 17.2, and then select this, control, select this and control, and select this. Okay, you have to press control. Inner walls there are no loads. Okay, then click on assign to selected beams, assign, and yes, this one has been assigned. So now let's go to this one. Okay, so select this display whole structure, front view. Now we just select this portion and right click, and then click on new. Okay, just click on this, select this also, like this, 1, 2, 3, make sure you press control, otherwise the selection will not happen. 4, like this, and right click, and then click on new view, click on OK, and then click on this portion, and then just take this 21.6 option, and here do like this, do like this. Let's see if everything has been selected or not. So everything has been selected here, as you can see here. 21.6 assigned to selected beams, assign, and yes. So this is done. Only for the terrace portion is remaining, terrace perimeter load. So display whole structure again, and front view again, and go to the terrace only now. Right click and click on new view, and then click on this particular view here. Terrace portion parapet wall load will be acting here, 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 and here. Make sure to press control while selecting. Assign to select beams, assign, and yes. Display whole structure like this, you can see 4.9, 17.2. just to do this 4.9, you can see the blue here, 4.9, 17.2 in the bottom floor, and the 26 point, this is the other floors. Similarly, this you can see here. Okay, this will come after the analysis. This direction is also come. Now let's do for the live load also. Okay, so for live load I can just save this model. I think we'll do this in the STAAD editor. Okay, analysis and design. So now utilities, command file, and let's zoom it for you, and then we'll do this in the editor here, live load part. So one-way load, this one will copy and this one will right click and paste it here. And in this one-way load, let's see what is for the terrace floor here. In the live load, terrace floor is 1.5. So just do this here, 1.5 in place of 5, we'll just place it 1. And then in the other floors, it is the live load is 4. You can see 4 here, and we'll just do 4 minus 4. And now once we have done that, we'll copy all the dead load part to the in the seismic weight. So in the seismic weight, the total dead load is taken and a percentage of the live load is taken. So in this case, for the terrace floor, 100% of the live load they've asked to take, and since it is more than 2, so therefore 50% will be taken automatically. But if you are using the old version, then you can copy the entire thing. But in the new version, if you are using the terrace load like this, then you have to insert the loads manually in the STAAD main interface. So except the flow load, I'll copy the other things. The flow load I have to insert manually. Okay, so once I just copy this, so I've copied the member load and I've copied the self weight. Okay, I've not copied the one-way loads here. These two things I have copied. Okay, so I'll press Ctrl+C, and here I'll go in the seismic weight here and then enter, and then Ctrl+V. Now in the seismic weight, there cannot be any direction or there cannot be any sign. So I have to remove the direction sign here, and in place of load, I'll just type here WEIGH. Sorry, there has to be caps. WEIGHT. That is the weight here, and the weight has been given here like this. And then obviously unit load here, UNI will be there, and there will be no direction here. For this is for the main walls, this is for the main walls of bottom of the plinth level, and this one is for the parapet walls. I know this, I'm just telling you because we have to recognize all the things here. And once this is done, you can press Ctrl+S, and then you can just close this. So once you close this, you can just go to the loading part and see the changes. First you'll see whether our changes in live load are done. You can see the terrace floor and this floor are done here. In the definitions also, I can see here self weight has been assigned, member weight has been assigned, member weight for 3 particular members have been assigned. Now in the seismic definitions, zone definitions here, we'll add here, and we'll add as our floor weights. Okay, one will add and the remaining will do in the STAAD editor itself, just to see how they are giving the groups. Okay, so we'll take the group here, one-way distribution obviously, and for the dead load we'll do other floors here. Okay, so other floors for the dead load is 5.5. okay, dead load on terrace is 5.5. so okay, on terrace let's do first 5.5. there will be no direction here, and click on add. Okay, so click on add, and I'll just close this because the remaining things we have to do in the STAAD editor, just to see how they are taking this command. Okay, so go to utilities and go to the command file and save this. Obviously I always tell the STAAD editor, but actually this is the Connect edition, this is the command file, so sorry for that. And here in this, let's go here, this is the part. So seismic weight, this I'm just identifying by this. Seismic weight has been defined here, and here we'll do remaining things. So that's what they're doing. Difference, as you can see, terrace 1 only there, just you have to remove the negative sign obviously, and also you have to add GX because we need a direction in which you need to give the loads, and that's why they are implying the GX here. So I'll just copy this here, copy and paste, and these two also copy and paste it here like this. So first of all, just do this and remove the sign here, and remove GY with GX, right? GX and GX. Now this for the terrace floor, this is live load part. Obviously terrace floor live load is taken 100%, and for the other it is taken as 50% since it is more than 2 as per table number 10 of the tire score. So you can see this. So sorry, what have I done? 2, right? So like this you can do Ctrl+S. Obviously check syntax is better because sometimes you do some errors which you might need to figure out. Okay, what is one message here? So check syntax is done, and concrete let's do M25 here for fully 25000. M25 concrete has been done here. Okay, FCU M25 density also you can change, I think, later, but okay, no, we will not change this now. Let us run one analysis first. Ctrl+S and then close. Okay, now go to okay, let's see the loading first. First of all, you can see in the seismic definitions, one-way load. You can see this terrace floor, all other load. This is there, and remember flow force is also there. SLX, SLZ is also there now. This is obviously earlier also done. So all these loads are there. So go to analysis and analysis commands, all, click on add and click on close. Now simply run analysis. Let's see if we have any error. So there are no errors here. Go visit, you can also visit the output file, and in the output file, just there are two warnings, tension, compression. Okay, there is no done. So just search here VB, base shear, and you can see base shear here is 1214.7 here. Find all. Okay, so all values are there, 1214.7 base shear. So now we can find base shear here. I've just given in the PDF base shear value starting. It is 1320 here. You can see in the page number 14, base shear 1320, 14 here. Yeah, this is base shear calculated to 1320. So what our value is coming? 1214. So it's around a difference of 100 kilonewton. Difference is coming. It is coming close, but then this difference is coming. So we can refine some things maybe, but let us just see. Okay, so this is the difference between this manual and the STAAD calculation we have done. By the way, you can refine this. If you find, then I will just tell you. Okay, so just close this. Okay, why have I? Yeah, just close the editor. Okay, so close the editor, and now we can go to utilities. Then go to command file here, and let's see here. In here we have the concrete, and this density, if we do this as 25. Okay, Ctrl+S and then close this, and then go to analysis and design, and then analysis, view output file, Ctrl+VB, find what, Ctrl+F, then VB, enter. So it is 1234. So it is now closer. Okay, now the value is closer. It is the difference has been closed by 10 more, I think. So you can see the value is closer now. Okay, so like this, there are some fine refining has to be done. We can also check. We can go closer than this. By the way, I'm using the STAAD connected edition. Maybe it may be possible that if I use the earlier version, I can get closer. Okay, in the connected edition, this results are there. So let's compare some other results to check whether our modeling has been okay or not, to gain some confidence. So I have just also mentioned it here. This is the shear force and bending moment check in the page number 19. Okay, so page number 19, you'll find the moment check. Okay, end moments here are there, and end moments for 6 basic loads DL. So B2001. So to identify what is B2001, so for that, you go above and you see the section here. First of all, just go to the plan first, that will be better. So it is A, okay, B, C. So B2001 means there will be some on some level, there will be first floor, second floor, but you don't know, but it will be along this beam. Okay, B2001. Okay, this will be in this beam, B4, B6, like this. So let's see here. So 1001 is on the bottom floor, and 2001 is starting on the first floor, you can say, or the ground floor slab. Okay, it's not the plinth level, it's the one floor of the plinth level. So that is the first floor again. So let's say let's call this first floor. So B2001 is 2001 is along the first floor. Okay, so now so B2001 is so this one C1, C2, C3, C4. So like this you can know. Just check this. I'm just showing you. I can tell this directly, but to show you that so that you can check also C1, C2, C3, and C4. So it means it is the first line. So 2001 is this one, first one. This means actually this is in this particular plan. This is this particular beam in the first floor. So in the CD will see, then this will be this particular beam. Okay, so the results of this particular beam we can compare here. So simply go to post. Okay, we can also just right click and maybe click on new view and see just this, because we're checking just this. Go to post processing mode. Okay, apply and dead load first, and we are going to apply here FY, and obviously we just annotate here. Select in this reports, annotate, and reactions, beam results. Just select everything for now. Okay, close. So for the shear it is coming 108 in one direction and 119 in other direction. So let's check here, page number 19. This is the moments. Shear is this. So 109 and 119. What is coming in our? It is 108.6 means 109 and 119. So it is pretty close, as you can see. So the structure is not wrong. Okay, it's pretty close. So then let's check the just turn off this and check the moments as well. So moment is coming 116.515 and means 11. You can say 117 and 159. So let's see here what is the PDF file. Just go above. So 117.95 and minus 157.95. Okay, so 116.5 means 117 is close, and 158 it was 157.9. so you can see the moments are also pretty close, which means the structure is correct. Okay, just practice this and see if you can go closer than this the results, and compare and let me know in the comment section. Make sure to drop a like to help the YouTube algorithm. Thank you, keep learning, bye bye.